Okay, everybody. So we're going to solve this little inequality here, x cubed plus 2x squared plus x. And we're interested in where that whole thing is less than or equal to 0. And so remember, what I'm going to do here is I'm going to use the graph of the function on the left there to help me answer this inequality. So what I want to do, and I'm going to use my knowledge of this function here, because I know what a cubic sort of looks like, particularly a positive cubic. So what I'm going to do first of all is we're gonna look at it like this: y equals x cubed plus 2x squared plus x. Now I know there's no y in the original inequality. That's okay. That's okay because I'm not going to end with a y. I'm just going to use this temporarily. So I want to graph this function right now, and to do that, I'm going to first of all take out the common x, and I get x squared plus 2x plus 1. And then I note that that quadratic there is actually the same as x plus 1 squared. Okay, so what does x times x plus 1 look like? And this is, I'm relying on people having some background information with this here. So the assumption is that you've seen this before. But what we're looking for here is now, if I'm going to look for, let's say, my x-intercept, we're going to let y equal to 0, which is an equation that we can solve here. And we're going to get that this occurs when x is either equal to 0 or negative 1. So I'm going to have my x-intercept here at 0. I'll do this in blue. At 0 or over here at negative 1. Now, what does the function look like? Well, it's a cubic, and it's a positive cubic. The leading coefficient is positive, so it's going to come up. Okay, it's going to come up from the bottom, and it's going to keep going up to the right here. That's just the overall behavior here. The 0 here, negative 1, has got a multiplicity of 2. And the x all on its lonesome here has got a multiplicity of 1, which means my function is going to come up. It's going to just be tangent to the x-axis there, and then it's going to cut right through when x is equal to 0. So that is, roughly speaking, what my graph is going to look like. So now my question is, where is this less than or equal to 0? Let's just take a quick look here. Well, to the left of the graph, I mean, it starts really low. It's coming up from negative infinity. So it's going to be below 0 there. Then it comes up and it starts to approach the x-axis, but it hits the x-axis at negative 1 and drops back down again. So it doesn't actually cross over. It doesn't get larger than 0 at negative 1. It bounces back down. So it stays below 0. And remember that my interval here is including the 0. So this is all good. To the left of the origin is all good. It's all less than or equal to 0. At the origin, it is equal to 0, and then beyond that, the graph becomes positive, is above the x-axis. So my answer is going to be really where x is less than or equal to 0. Or if I write this in interval notation, negative infinity up to 0, and we're going to include it. Now, just to make this interesting, if the question had been this, if it had been x cubed plus 2x squared plus x less than 0, in other words, if it had not included the 0 up there, then what would happen here is that value here at negative 1, the y-coordinate would have become 0. We wouldn't have accepted that. We would have rejected that root. So what would happen here is, it's true, the function is less than 0 for all values of x less than negative 1. And then from negative 1 out to 0 also works. But as soon as I hit negative 1, the y-coordinate is 0. As soon as I hit 0, the y-coordinate is 0. And beyond that, to the right of 0, it's always going to be positive. And so what happens here, I can write this in interval notation. This would go from negative infinity to negative 1, not including the negative 1. That's where it goes to 0. Together with negative 1 out to 0. And that would be my solution to that equation, if that's what it was asking. I just wanted you to see the difference between the two.